Okay, so as I was saying at the end of the last video, this is charging by conduction, this first example. Okay, we're switching charge, we are transferring charge because two objects are touching. I have an example. I took the liberty of writing it out while I was downloading the second video there. Here's your example. You've got two metal spheres. One of them has a charge of 3 times 10, positive 3 times 10 to the negative 6 coulombs. The other has a charge of negative 4 times 10 to the 6 coulombs. They are brought together, these objects, to touch briefly before then separating. What are the charges once they separate? You've got to remember, charges want to get away from other like charges. They want to spread out. And if they see an opportunity to go to an object that is less negative, okay, if they're on an object that's more negative, they want to go to an object that's less negative, they will take that opportunity. So here's our two objects. In order to figure out what the final charge will be on these objects, we have to do two things. First step, find the net charge by adding the charges together. You need to include the sign for this, okay? You can't just do 3 and 4, okay? You can't just do 3 times 10 to the negative 6 and 4 times 10 to the negative 6. This is a negative, you need to include that. So let's do that. We add those together, we end up with negative 1 times 10 to the negative 6 coulombs. That means the net charge is negative, okay? And then our second step is to divide the net charge by the number of objects. I'm splitting charge between two objects. You might, in some cases, have to split between 3 or 4. Okay? I divide this by 2, and this becomes 5 times 10 to the negative 7 coulombs. If you don't believe me, get a calculator and do it for yourself. So, oh, and that is a negative 5, excuse me. So what happens here is we end up with two objects at the end that have equal charges. Okay? We started with two objects that were unequally charged. We end up with equal charges on the objects, if at all possible. Okay? There are some situations where you cannot have equal charge on the objects. That's all right. Okay, that's not too big of a deal. There's charging by conduction. The last method of charging is the most complicated one, and it is charging by induction. So we have conduction and induction. Induction is really the one that I think gets most people because it's kind of complicated. There's 3 or 4 steps to it, no matter how you charge by induction. And there's 2 different methods for charging by induction. We'll go over both of those. But this should be a review from last year. So charging by induction. This, for in both cases, is charge transferred through polarization first, okay? The polarization doesn't transfer charges, but it's an important step. We have to polarize the object, and then either through grounding the object, or separating one object into 2. The important thing with charging by induction is that there is no actual touching between the charged object and the objects that you're changing the charge of. Okay, there's no actual touching, especially with a grounding one. Okay, so there's no actual touching of objects. And like I said, there's 2 different ways. I call them grounding and separation. Let's do separation first, because I think that's a little easier to understand. So separation example. Let's say you have 2 objects. That is not a good circle. There we go. They are right now combined. And they are neutral. Okay? Because they're neutral, we could even say that they have a net charge of 0 E. Here's what we're going to do to those objects. We're going to disturb their neutrality. We are going to bring in, I know I keep using negatively charged, this could just as easily be positively charged. We bring in a negatively charged object to our little neutral party over here. Okay? Now what's that going to do? This is going to polarize. Notice that, hopefully you can see it, there's a little bit of space. This is not touching. First we are polarizing these. This is polarization. What's going to happen? The negatives in our 2 objects right here do not want to stay near the negatives in the new object we've introduced in this rod. They're going to flee. They're going to go like this. Positives get left behind, these positives don't move, but now this object has all the negatives, or this half of the object. So we've split the charge, we've separated it into two different objects, and then, well, what if we took this object and we broke it up, we broke it in half, we separated the objects, okay? We separated this object while we're still polarizing it. So while this is still here, we split these objects up. Once we split them up, we could take away this, the negative object. There's no way that these negative charges, these electrons, are ever going to get back over here. So they're stuck there, okay? They're stuck in that rightmost object. Now we have two objects. I have polarized, I have charged these objects without ever touching this charged object to them. So this is different from the first two times. Both first two objects, or the first two methods of charging, there was touching between a charged and an uncharged object. This is not the case here, okay? We are simply inducing a charge and then doing something about it. The net charge on this is now plus 2e. Charge over here is negative 2e. The total, I haven't changed the amount of charge in the object, okay? But I have, like the total object, but I have split the charge up into two different places, two different objects, and I have separated them. Now, this has a positive charge, this has a negative charge. That is charging by separation. Now we're going to do charging by grounding. Again, we're going to start with a neutral object. Here's our neutral object, plus minus, minus plus. Okay, net charge is 0e. We're going to start it off the exact same way. We're going to bring in, let's do a positive rod this time. Plus, 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 plus. Now think about how the charges are going to behave. This isn't going to make the positives move away. The positives are stuck in place. Instead, what it's going to do is it's going to attract the negatives up here, close to, let's make it so it's a little bit more visible. It's going to attract the negatives closer to the positively charged object. Okay? So, we've got this object coming in. My object is polarized. While the polarizing object is still present, we take our neutral object and we do something with it. We attach it via wires or some sort of conductor connection. I know I'm kind of running out of room here. We attach it to what we call the ground. Essentially what that means is it is attached to something that is attached to the Earth. The Earth is a huge repository of electrons, okay? The Earth is so big that the Earth is not really going to miss 1 or 2 electrons, or even like a couple million electrons going into an object, okay? The Earth has so many electrons in it, it's not really going to make a difference overall if the Earth takes that, if you take those electrons away. I mean, obviously it won't be completely neutral, but the Earth is so big it's not really going to have too much of an effect. So this is the symbol for ground. It's kind of like an arrow with like these lines here. And what's going to happen is, from the ground perspective, this object now looks like it's positive. So you take electrons that are in the neutral Earth and you show them a positive area or a positive place, they're going to be like, hey, let's go over there. That's a lot less negative than neutral, okay? If it's positively charged, or it seems positively charged, those electrons are going to be drawn up the wire, up the grounding wire, into the object. So we have electrons come in from ground. They come up the wire just like this. And then, what you do, in this order, has to be in this order, is you remove the ground. So essentially you don't let those electrons out, and then you remove the object. It has to be in that order. I'll put then. And here's what you're left with, okay? If you remove the ground, those electrons can't get out. They can't leave again. If you were to remove this first, the electrons would just go back into the ground, okay? Cut the ground first, make it so they can't get out. Sounds like a horror movie. And then you take this away. what you're left with, the positives stay in place, but now you have these 2 electrons and you have an additional 3 electrons. Did I ever touch this charged object to this object? No. Instead what we did was we grounded it, we allowed electrons to come in, or the other way this could happen is the electrons flow out, and excuse me, and now we have a net charge. We have a net charge because we took electrons from the ground, we brought them into the object, I now have a charged object. So, charging by induction is the trickiest because there are so many steps to it. Charging by friction, very easy to understand. Charging by conduction, very easy. These are a little more complex because they involve polarization first. Okay? They involve polarization first, they're a little bit trickier. Those are the 3 types of charging. Charging by friction, charging by conduction, and charging by induction. All 3 of these can be done to what is known as an electroscope. An electroscope is a little apparatus that I will actually go try and find one now. Maybe I'll bring it in front of the camera. Do I have one out? I do. I have a whole bunch out. Okay. So, Regents, former Regents kids, you guys saw this last year. Here's an electroscope. I have no idea how well this is going to show up on video. Okay. But here it is. Actually, wait, I can just go over here and look. Okay. The electroscope is an insulated box. And in the box, there are 2 leaves, gold leaves. And what we can do is we can give a charge to the electroscope. The charge usually goes down into the leaves. And if the leaves become charged, if there is a charge, they will separate. Okay? You can look this up online. You can go and do this in the back of the classroom if you want to see them. But the leaves will separate when there is a charge, positive or negative. Okay? So the electroscope is really a tool for telling if there is a charge on an object or not. So, an electroscope is an object used to determine the type of charge present on an object. Okay? I'll draw a real quick, very ugly sketch of an electroscope. There is a box, like this. There is kind of like a metal stand, and on top of the stand is a metal knob. Okay? At the end of this metal stand, there are some hooks, like this, looks like an alien, and then there are some metallic leaves down here. And this around it is a glass casing to prevent leaking of charge. Okay? So, the electroscope. I guess it can't be charged by friction, but it can be charged by either conduction or induction. It can be charged by conduction or induction. One of the 2. And this object, whenever it becomes either polarized or charged, you will know it because the leaves spread apart. Essentially what happens is if you either separate the charges in the electroscope when it's neutral, or if you if you give it a charge, those charges will go down into the leaves. And the leaves will both have positive charge, or like the total negative charge will go into both leaves. You'll have both leaves being negative and negative, or positive and positive, and they will repel. There is no such thing as getting a positive and a negative leaf. That does not happen, okay? Sometimes the leaves kind of snap together. That's just a mistake, okay? That's not something that should be happening. So, if you know, if original type of charge is known, so if you know what type of charge is right now on the electroscope when the leaves are spread out, based on what it does, you can determine whether a negative or positive object was brought near it, like a second object, okay? So can determine charge of other exterior objects by examining, yeah, there we go, leaves. Okay? So you have to know what type of charge is on here to begin with, which isn't too hard to do, but then, once you know that, you can determine if other objects are positive or negative by bringing them near the electroscope and observing what happens. So, let me start writing an example. Let's say that you know that your electroscope has a negative charge on it. What happens if a positive object is brought near it? Okay. So the charge on the electroscope is negative. Okay? That means the leaves are separated. You bring a positive object near it. What's going to happen? Well, the leaves right now have excess of negative charge. You bring a positive object near the metal knob, usually that's where we bring objects near. The positive object will attract the electrons from the leaves. Fewer negatives are going to be in the leaves, fewer electrons. And if there's fewer electrons in the leaves, then they're not